तो हालांकि इसमें ना there was just one thing that was missing and that was कि अच्छा जो बिल्कुल लास्ट चीज है that was missing was कि well it's just a statement which is that and this is only for and this applies only for first order reactions. So what that is कि it means that k is basically the rate constant which is 0.693 divided by the half life. Okay, so for only for first order reaction, the rate constant k in the rate equation, उसका एक formula है, ठीक है, which is basically can remember every equation that we did, all the rate equations that we did, ठीक है, we came up with there was कहाँ पे हमने कहाँ पे rate equation लिखी थी, हाँ, so whenever you write a rate equation, the rate equation was that how is the rate dependent on O2 and the reactant concentration, right? Rate is proportional to NO's concentration power A and O2's concentration power B. Or to get rid of the proportionality, we added a K. ठीक है? तो ये जो K की value है ना, this if it's a first order reaction. So that is if it's a first order reaction, the value of K could be calculated using this method, which is where T half is basically the half-life. Okay, this is the half-life. So the time taken for the concentration to decrease by half, if you know that, वो जो graph हमने शुरू में नहीं किया था, so if you know that, you can calculate the rate constant K without, as a rate constant K, now there are two ways of finding the rate constant K. One is, okay, once you have the rate equation and once you have the order, so you just plug in the data, rate key value, plug in the rate value, plug in the NO concentration, plug in the O2 concentration. You already know what the order is. Once you have found everything, okay, you plug in the data that's given and you find the value of K. That's it. So they're going to ask you. So it's pretty obvious. We do past paper questions and we'll get that. So I'm just going to recap the whole chapter. Okay, the whole chapter was there was a simple thing. There was order of reaction. There was relationships. This was order one. Order one was you increase concentration of A, the rate increases. Okay, that was order one. Okay, rate was dependent on the A's concentration. If you track the A's concentration with respect to time, if it decreases, the reaction slows down, so it takes longer and longer time. So the half-life remains constant. Then there was order zero. Order zero was that rate was not dependent on A's concentration. That meant that yeah, no matter what the concentration of A is, the rate will not change. The speed with which A's concentration decreases with respect to time, that will not change because the reaction will not slow down. It will maintain its speed. Okay, second order was that you increase A's concentration, the rate exponentially increases or decreases. Or the half-life doubles. It takes longer and longer for the reaction to finish. Because if A's concentration goes down, the rate of the reaction slows down by a much bigger margin. So every time the half-life doubles. ठीक है, तो ये सारा था. We did mechanisms. I told you that when it comes to mechanisms, the entire speed of the reaction depends on the slow step. So any reactant that is involved in the slow step, that is order one. Okay, anything that's involved in the slow step, that's order one. Anything that's involved in the fast step, that's order zero. Okay, वो सब किया था. And then last thing we did was we did the experimental thing, which is that you're going to do experiments. Okay, for example, experiments one and experiment two. The concentration of NO is halved, and the rate over here becomes 1/4. That means it's order two. The relationship is order two. So we're going to jump to past papers. We've pretty much covered everything, so we'll just directly jump to past papers. Oh, but I've sent the past papers in the group as well. तो यहाँ पे थे ये वाला. अच्छा, so we're going to start doing questions now. Again, we're going to start doing complete questions now. We did a few last time as well. So for example, this one. Okay, this is the experimental method of finding the order. I think we did this one. Okay, how would you find the order? I mean, let's try and do this again. How would you find the order with respect to, let's say, NO? So what I'm going to do is I'm going to change NO, and I'm going to see what effect would that have on the rate of the reaction. So if I compare experiments 1 and 3, I want to keep O2 constant. So experiments 1 and 3 is that O2 remains constant. That's why I picked experiments 1 and 3. So NO concentration, what happens to it? It's halved. What happens to the rate of reaction? So which factor, if you want to find out what the factor is, so what you need to do is take this number and divide it by this number. If you do this on your calculator, this will come out to be 1 by 4. Okay? So that is order 2. That is an order 2 relationship squared. So the way you're going to answer this is that if you compare experiments 1 and experiments 2, NO concentration is halved and rate becomes 1 by 4. Hence, order with respect to NO's concentration is, I mean, it is order 2. Achha, here again, it's you have to find order with respect to O2 now. So if you want to find order with respect to O2, what you need to do is, okay, I want O2 to change so I can figure out how the rate changes. But I want NO to remain constant. So in that case, we're going to compare experiments 2 and 3. So this is becoming half. And this, I think, is also becoming half. Calculator, but you can take this value and divide it by this value. So you will find out that it is also being halved. Okay, so that is directly proportional. That is order 1. Okay, O2 go half ke, and the rate is also halving. So you're going to compare. So what you're going to write is that if you compare experiments 2 and experiments 3, so the concentration of NO, of O2, sorry, is, okay, so the concentration of NO is, O2 is halved, and your rate is also halved. Hence, it's order 1. Order with respect to O2 concentration is 1. So I figured out the order with respect to both of them. Ye clear hai, Umar? Hala, Baba, is this clear?
Yes, sir.
So state the rate equation for this reaction. Use the rate equation to calculate the rate constant. So the rate equation, we know this now. Okay, rate is dependent on NO's concentration or uska order kya, that's with respect to NO, that's 2. So with respect to NO, it's 2. And with respect to O2, so with respect to O2, it's coming out to be 1. And sometimes they're going to ask you the overall order. Okay, remember that the overall order is 3. दोनों का order जो है ना वो मिला दो, it's the overall. एक का 2 है, दूसरे का 1 है. So the overall order in this case is 3. Now he's asking you to figure out the rate constant K. And use the rate equation to calculate the rate constant K. So what I'm going to do is, I have values for experiments. Okay, for example, experiment number 1. I'm going to plug that data into this equation. The only unknown is K. Okay, so the rate is given, that's 3.5. K, I don't know. NO's concentration is given, that's 0.1 squared. And O2 concentration is what? 0.05, and that's power 1. So I just need to solve this. K would come out to be 3.5 divided by zero point 0.1 squared times 0.05 power 1, right? ये अगर calculator है तो मेरे से पहले solve करने की कोशिश करो कि what's the answer to this? 3.5 divided by 0.1 squared. So 0.1 square का पता किधर है एक सेकंड हाँ square into 0.05 अच्छा वो power 1 that is not squared ठीक है it's coming out to be I mean for me it's coming out to be 7,000 I don't know if it's the calculation में गलती तो नहीं है so that's 7,000 ठीक है that's the rate constant and he's asking you to figure out what the unit is so I mean that's just homogeneous equations that's just physics you're going to take the units that are given over here ठीक है rate का given है it's mole per dm cube per second so my rate is अच्छा mole per dm cube को just to simplify I'm going to take mole per dm cube as x so mole per dm cube per second that's rate is equal to k then it's NO concentration that's mole per dm cube that's squared so that's going to be x squared times O2 concentration that's x ठीक है so if I solve for k it's going to come out to be x divided by x cubed so that's basically x to the power minus 2 and it's s minus 1 and k was what k was but this x was mole per dm cube so that's going to be mole minus 2 dm6 and s minus 1 that's my unit clear है कि unit किस तरह निकला is this clear
Yes, sir.
that's the next one now he says the initial well, it's another question. He says that the initial rate of reaction of propanol and iodine in acid solution is measured in a series of experiments at constant temperature. The rate equation was determined experimentally to be as shown. तो अच्छा एक मैं ना एक मेरे दिन में एक चीज आई है I'll just add this to the notes is that so there's some extra points. ये paper 5 में ना it's going to come in handy. So suppose we have a reaction and we want to figure out ये वाला कर लेते हैं. So suppose if I have a reaction, is this balanced? As I say, if I have this reaction and I am investigating this reaction and I know that rate is proportional to NO's concentration power A and it's proportional to O2's concentration power is B. I don't know what the order is and I'm trying to find this out, right? So when I do experiments, I want to keep one of the concentrations constant, right? Uh, for example, I want to investigate this relationship that I want to find out how rate varies with respect to NO. Okay, so this is what I'm trying to figure out. I don't want O2 to be affecting rate. I want O2 to be constant. Now remember one way of keeping O2 out of this equation. ठीक है ताकि उस मतलब क्योंकि problem is that if O2's concentration changes, it will affect rate. So my whole relationship will get affected because I was trying to figure out how NO affects the rate, right? Now, in any experiment, as the reaction proceeds, O2 concentration will also decrease. It's going to get used up, right? So O2 concentration will decrease over time, right? And it will affect, or it will have some effect on rate. So I don't want O2 to interfere. So how do we prevent that? The way you're going to prevent that is that you're going to keep O2 in large excess. यानी अगर सिर्फ ये relationship आपने find out करनी है, if this is the only thing you're trying to investigate, right? And you want O2 to have nothing to do with this. So O2 is kept in large excess. In very large excess. So any change in its concentration over time is negligible in its concentration over time remains it remains negligible. Let me explain this. So for example, this is 0.01 mole per dm cube, right? Or O2 की concentration, I'm going to keep it as 1 mole per dm cube. So that's like कितने times? 100 times? That's like 100 times greater, right? So I want to figure out, so what's going to happen? NO concentration, let's say, decreases by half. So कितनी हो जाती है? 0.005 mole per dm cube, right? So since let's assume that they're reacting in 1:1, right? O2 will also react with it. But the thing is कि अगर इधर 0.005 concentration has decreased, right? I mean 0.005 NO has been used up, right? तो ये थोड़ा सा यूज अप होगा ना इसका हाफ 0.0025. So if you subtract one में से ना, if you subtract because you already had 1 mole per dm cube, so one में से if I subtract 0.0025, I get 0.9975. मैं इधर भी लिखता हूँ, if 0.005 is used up, so how much O2 would be used up? 0.0025. So 0.01 में से if 0.005 got used up, you're left with 0.005. That is a 50% decrease in concentration for NO. लेकिन O2 पे क्या फर्क पड़ा है उसका? If 0.0025 gets used up, it's still approximately still 1 mole per dm cube, right? पर उस पर कोई खास फर्क नहीं पड़ा, ठीक है? So anything that's in large excess, its concentration practically over time would remain almost negligible. तो इसका मतलब है because its concentration is barely changing, it will really not have any effect on the rate of reaction. All the effect on the rate will be caused by a change in NO's concentration क्योंकि वो तो 50% decrease हुआ है ना, ठीक है? तो ये बात क्लियर है सारों को? मावा, इज दिस क्लियर? उमर, हाला, इज दिस क्लियर?
Yes, sir.
दैट भी कर लेते हैं practically. No change in practical terms or negligible change. और यहाँ पे क्या है कि significant change, NO's concentration decreases by, it decreases by half. So that comes especially handy in P5. Achha, anyways, he's seeing the rate equation. Achha, this question is easy. The rate equation is already given to you. ठीक है? तो वो कह रहा है कि state what the order is. Well, the rate equation is right in front of you. Okay, so if so you just have to read it. CH3, CH3. That's obviously order one. अब अगर कुछ नहीं लिखा, that's obviously order one. That's power one. H plus one is also power one. Now I2 is missing, so that means I2 must be order zero. That's why you don't write it, right? So it's obviously order zero. And state the overall order of the reaction. So the overall order of the reaction is you sum up the powers, and that's going to be 2. Next part may calculate the rate constant and calculate the what the fuck you likha? I say it's the same. It's been copied twice. Now you know the rate equation. All you have to do is you have to. अच्छा एक सेकंड देना वो डिस्कनेक्ट हो गया. अच्छा चलिए ठीक है. अच्छा, so the equation is given. All you have to do is you have to plug in this data in this rate equation. I'm just going to do that. So the rate is given as 5.4 times 10 power minus 3. So 5.4 times 10 power minus 3. I don't know what K is. He's asking you to figure out what K is. And CST, CO, CST, that's 1.5 times 10 power minus 2 into times H plus 1 is given. That's 7.75 into 10 power minus 1. Or I2 is nothing. I2 is not even part of the equation. Okay, uh, so you have to do two things. You have to find the value of rate. तो वो कर लो कि कितना है वो. It's 5.4 exponent minus 3 divide by ये क्या होता है point 0.015 और फिर that's divided by 7.75. नहीं sorry 7.75 नहीं है 0.775. अच्छा I'm getting 0.69 ये 70 हो जाएगा. So I'm getting K as 0.700. ठीक है in this case. And the units I have to calculate. So units is we're going to use the units that. As I remember, make sure kabhi bar he changes the units as well. So make sure okay, you double check. You're going to use the units that are being used over here. So it's mole per dm cube per second. So I'm just going to take. I'm going to take mole per dm cube as x. The mole per dm cube per second, K times mole per dm cube times mole per dm cube. So it's so K would be x over x squared. That's going to be x minus 1 and minus 1 to pehle hai. And that's going to give me mole minus 1 dm3 s minus 1. That's going to be my units. Okay. So this was an easy one because he had given us all the values. Or as a complete a table placing one tick on each, describe the effect of decrease in temperature on the rate constant and on the rate of reaction. So अच्छा एक ये भी चीज मेरे ख्याल से clear कर लो. Whenever you decrease temperature, the rate of the reaction also decreases. Because the rate of reaction also always decreases. And the reason it decreases is because the rate constant, remember, is a constant. उसका भी बता देता हूँ. It's like any equilibrium constant. It only changes with temperature. ठीक है, ये उसमें add कर देते हैं notes में. Another small point के the rate constant K it only changes with temperature. And with temperature, it actually decreases with temperature. It slows down the reaction. Okay, so the rate constant K also decreases. So ये बात याद रखिए, rate constant K, like equilibrium constant, only changes with temperature, or unlike equilibrium, it always decreases with temperature. वो reaction को slow कर देता है. So okay, describe how this graph could be used to determine the initial rate of the reaction. So all you have to do is you're going to not plot, calculate the gradient. Plot the पहले ही हुआ है. So you're going to calculate gradient at t is equal to 0 seconds. So उसके ऊपर जाके ना, that's what is needed, right? You're gonna calculate the gradient at t is equal to 0 seconds. बस ये gradient का एक mark होगा, t is equal to 0 seconds. That's the other mark. Next one is on the axis, sketch a graph to show how the initial rate changes with different initial concentrations of this thing. Now this was order 1. ये ऊपर हमने भी किया. This was actually order 1. So order 1 is directly proportional. So the rate of the reaction will, a straight line, okay, it's just going to increase with. You keep on increasing the concentration, the rate of the reaction will continue to increase. The next one is, okay, explain the meaning of the rate determining step. So it is what? It is the slow step in the mechanism of the reaction. So it is a slow step in the mechanism of the reaction, and determine the overall equation. How do you determine the overall equation? You add up all the equations. Well, step 1 is step 2, step 3. You're going to add up all of them. Things that appear on both sides, they're going to get cancelled out. क्या आ रहा है दोनों sides? So Mn4 plus comes on both sides. Is there anything else that comes on both sides? No. The Mn2 plus gets cancelled out as well. So the overall equation is that C left side, add up the left side, add up the right side. Left side is I see 2Ce4 plus, and I see Tl plus 1. अच्छा दूसरी side पे I see 2Ce3 plus, and I see Tl 3 plus as well. ये मेरी right side पे. I was suggest the role of Mn2 plus ions in this mechanism. Explain your answer. So the Mn2 plus is what? It's your catalyst. It's वो यहाँ पे और बाद में it's getting reproduced at the end as well, right? So it's a catalyst. And what type of catalyst is it? It's an homogeneous catalyst. So 2 marks ka, so it's a homogeneous catalyst. Remains unchanged at the end of the reaction. So it kind of provides an alternate path, and it is in the same phase as the other ions, as the reactants. So that is basically because of so the Mn2 plus kind of remains unchanged at the end. ठीक है, clear है सारों को? मैं clear है? हाँ ना? Mama, is this
Yes,
clear?
sir.
अच्छा, next one ये तुमने last time हमने कर लिया था. ये फिर से वो आया हुआ है, temperature and rate constant, right? So remember this, that you keep on increasing temperature, the rate constant increases with temperature. You decrease temperature, the rate constant decreases with temperature. Now we're saying, in another experiment, the reaction between chlorate 1 ions and iodide ions in aqueous algae was investigated. अच्छा, वो large excess of chlorate 1 ions are being added. That means he's not investigating that. He wants them to remain unchanged, right? So that means throughout the reaction, the concentration would be, in that case, would be constant. Okay? It's going to be completely constant. So a solution of iodide ions, or वो regular time intervals के ऊपर ना, he's measuring it. वो कह रहा है कि how would you confirm the reaction is first order? Now if he plots the concentration of iodide ions versus regular intervals, any time intervals, then what you can do is you can measure the half-life. Measure the half-life. How much time does it take for iodide concentration to decrease by half? So concentration, what is half-life? Concentration of I minus 1 to decrease by half. Now for first order reaction, this is going to be constant. better words where half-life would be. So you're gonna just check for that. Yeah, for a first order reaction, the half-life is a is constant. It's not going to change. और दोबारा सोचेगा कि overall equation. So again, overall equation is add up the left and right. Things that appear on both sides will cancel out. HClO, HClO. और कुछ है? OH गया. HIO चला गया. सारी चीजें तो चली गई. I minus one will stay. Yeah, so the only thing that's left is ClO minus one on the left side. I minus one on the left side, and on the right side, I've got Cl minus one, and I've got IO minus one. और से identify redox. तो redox जो है ना वो probably ये वाला है. The minus one है. I over here is plus one, so that's redox. Cl is plus one over here, and I over here is minus one, so that's step number two. ठीक है, that's redox. इस वाले में. So that is redox, and you have to explain your answer. So how do you explain your answer? Ki I minus one gets oxidized from minus one to plus one, and वो दूसरा जो है ना that gets HClO gets reduced from plus one to minus one. ठीक है. चलिए ठीक है मामा. मेरा ये हम फिर नेक्स्ट टाइम करते हैं कंटिन्यू. ठीक है. ओके एवरीवन.
Okay,
टेक केयर.
sir.
हाफिज.
Okay, Allah Hafiz.